Hello friends, welcome to my YouTube channel Maths DNA from origin to infinity. Before we begin, let me ask you a question. What can you serve but never eat? Think about it and you can comment your answer below in the comment box. This is my 13th lecture on real analysis. The topic is important tests for convergence of series with positive terms. In this lecture, we will discuss about comparison test, p-test, D'Albert's ratio test, and Cauchy's nth root test. So let us begin. Comparison test. If summation un and summation vn are positive terms series with k greater than 0 and there exists m belongs to n such that un is less than equals to kvn for all n greater than equals to m, then summation vn converges implies summation un converges and summation un diverges implies summation vn diverges. Let us understand this more clearly with the help of some examples. Example 1. 1 plus 1 by 2 raised to 2 plus 1 by 3 raised to 3 plus 1 by 4 raised to 4 and so on is convergent or divergent. Here take un is equals to 1 by n raised to n and vn is equals to 1 by 2 raised to n. And we know n raised to n is greater than 2 raised to n for all n greater than 2, which implies 1 by n raised to n is less than 1 by 2 raised to n. And summation 1 by 2 raised to n is a geometric series with common ratio 1 by 2, which is less than 1. So it is convergent, which gives us summation 1 by 2 raised to n is convergent implies summation 1 by n raised to n is also convergent. Example 2. Summation n running from 2 to infinity 1 by log n is convergent or divergent. Here take un is equals to 1 by n and vn is equals to 1 by log n. And we know log n is less than n for all n greater than 1, which implies 1 by n is less than 1 by log n. And we know that summation 1 by n is a divergent series, which implies summation 1 by log n is also divergent. Then p-test. The series summation 1 by n raised to p is convergent if and only if p is greater than 1. For example, summation 1 by n square and summation 1 by n cube. Then we have D'Albert's ratio test. Now let an be a positive term series such that limit n tends to infinity an plus 1 upon an is equals to some number k. Then summation an converges if k is less than 1. Summation an diverges if k is greater than 1. And the test fails if k is equals to 1. Let us discuss an example based on it. Example 3. Test the convergence of summation n running from 1 to infinity 1 by n into 3 raised to n. Now here an is equals to 1 by n into 3 raised to n and an plus 1 is equals to 1 by n plus 1 into 3 raised to n plus 1. Now we apply D'Albert's ratio test, which gives us limit n tends to infinity an plus 1 upon an is equals to limit n tends to infinity n into 3 raised to n upon n plus 1 into 3 raised to n plus 1. The n gets cancelled from the numerator and denominator and 3 raised to n also gets cancelled, which gives us limit n tends to infinity 1 upon 1 plus 1 by n into 3, which is equals to 1 by 3, which is less than 1, and therefore the series summation n running from 1 to infinity 1 by n into 3 raised to n is convergent. Then we have Cauchy's nth root test, which says let an be a positive term series such that limit n tends to infinity an raised to 1 by n is equals to some number k. Then summation an converges if k is less than 1. Summation an diverges if k is greater than 1. and test fails if k is equals to 1. Let us solve an example based on it. And also remember that limit n tends to infinity, n raised to 1 by n is equals to 1. Example 4. Test the convergence of summation n running from 1 to infinity n raised to 1 by n minus 1 whole raised to n. Here an is equals to n raised to 1 by n minus 1 raised to n, and we apply Cauchy's nth root test, which gives us limit n tends to infinity an raised to 1 by n is equals to limit n tends to infinity n raised to 1 by n minus 1 whole raised to n and whole raised to 1 by n. The n gets cancelled out and we get limit n tends to infinity n raised to 1 by n minus 1, which is equals to 1 minus 1, which is equals to 0, which is again less than 1. Therefore, summation n running from 1 to infinity n raised to 1 by n minus 1 whole raised to n is convergent. Thank you, and get the best material for preparation by just one click. The link is given below in the description. And also check out my other 30+ videos on my YouTube channel.